Hey guys, BuildZoid here, and welcome to the HWbot score roundup number 20. It's super late, and I don't have a good excuse for why it's so late, so yeah. It's here now though, so let's get into it. Starting off with OGS's 3D Mark 03 world record. So, for those of you who don't know, OGS is a two-man overclocking team from Greece. They are supported by Asus, Crucial, Galax, Thermal Grizzly, and Be Quiet. So, if we look at the system here, we've got the Be Quiet power supply. There's Thermal Grizzly, Thermal Paste probably under everything, memory, CPU, yeah, everywhere. GPU, of course, as well. The GPU is a Galax Hall of Fame, the motherboard a Maximus 13 Apex, and I believe for this score, the memory used is going to be some Galax Hall of Fame memory, as they're running 4,000, like the memory's running at 4200, 12, 12, 12, 20, which is Samsung BDI, of course, and Crucial does not sell Samsung BDI based memory kits. Yeah, so 3D Mark 03, a very old benchmark. It's from 2003, and a very interesting benchmark. Like the thing is it's super old, and yet it apparently scales to the point that it's worth it to run a 3090 at 2.9 gigahertz, at almost 2.9 gigahertz on the core and 1405 megahertz on the memory. And you know, and admittedly, it is still CPU bottleneck, so you do need an i9-11900K going, slightly over 7 gigahertz in order to feed the 3090. But the benchmark runs at absolutely ludicrous frame rates. Are you kidding me? Why? Opening photos from HWbot in a there we go. Yeah. Like I said, ludicrous frame rates. Over 3,000 FPS across all of the well, actually that's all of the tests in the benchmark are just over 3,000 FPS. And so that's of course why you need a 7 gigahertz 11900K. But what's interesting is that the memory is actually tuned for low memory latency rather than memory bandwidth, which is why we're looking at 4200 CL12, because that's going to be a Gear 1 running in Gear 1 with 1T command rate, 6.4 gigahertz ring clock, and the benchmark may scale to, absolutely insane levels of GPU performance, but it still doesn't understand what a core number 5, 6, 7, or 8 is. So the 11900K is downcored to just 4 cores and 4 threads, as I guess the benchmark actually knows what to do with 4 cores and 4 threads. Not really a benchmark I run myself very much. It's not as bad. Like, at least it doesn't require Windows XP. Like, looking at this score, this is very obviously running on Windows 7, so at least it doesn't require Windows XP. Yeah, like this is a benchmark that does have some sort of like software things to it. Because if you actually look at the overall rankings, so obviously OGS is at the top right now with their crazy fast 3090 and just all-around fastest system to ever run the benchmark, right? But then if you look further down in the rankings, you have like 1080 Ti's beating 2080 Ti's, and then also 2080 Ti's, barely squeezing past Titan X Pascals. And yeah, like everybody's running these cards. Well, okay, this isn't on LN2, I don't think. But the top, what is it, like top 10-ish, is it? Top 9. So the top 9 scores are all with the GPUs on LN2. So this is a wacky benchmark in the sense that, like, it scales with, the CPU, memory, the GPU, it's ancient, it runs at thousands of frames per second and has run at thousands of frames per second for a long time now. And yet it still isn't so CPU bottleneck, because there's other old benchmarks where you can literally leave your GPUs at stock and it doesn't make a difference to the score, like whatsoever. And so I find 3D Mark 03 very interesting in that, like, apparently, because running a 3090 at 2.9, almost 2.9 gigahertz is not something you just kind of do. It's not very easy. So, if you're pushing a 3090 that hard, it has to be for some performance benefit in the actual benchmark. And I'd hazard as a guess that the performance benefit's not very large. but still, it is like really interesting that that we have this old benchmark that just seems to scale with everything, and so that makes it super interesting. Unfortunately, not a benchmark I really run because there is also some software things to it. At least I suspect there are some software things to it because that's sort of the norm for a lot of these older benchmarks. And the last thing I don't really particularly enjoy the software end of overclocking, right? Like setting LOD on NVIDIA card, like disabling tessellation on AMD and setting level of detail on NVIDIA is about as far as I really care to go. And I think 3D Mark 03 requires a bit more than that. Yeah, so congratulations to OGS on the crazy score in like this is a very competitive benchmark and also just like a really interesting benchmark in that like yeah, you can run the like max out the GPU, max out the CPU, max out the memory, max out everything. Everything has to be as fast as possible. And we have other benchmarks like that, but this one is unique in that it is so freaking old and it runs at such high frame rates. So yeah, congratulations to OGS on the 3D Mark 003 world record. And let's move on to the next score, which is Splav's HWbot X265 8-core HWbot X265 4K top score. So for 8-core CPUs using a Ryzen 7 5800X. And Splav posted this score right after OGS posted their 8-core X265 4K run with the 11900K. So the X265 4K, this is a video encoding benchmark. And Splav is supported by ASRock, so Splav is running an ASRock X570 Aqua, G-Skill, Samsung BDI-based memory sticks, 3800 CL14. This is a pretty stressful benchmark compared to a lot of the other benchmarks on HWbot, both in terms of like memory stability and CPU stability. Also, it needs quite a lot of memory if you're going to be using the overkill function, which not a benchmark. This is another one of those benchmarks that I don't run very much. I've not figured out how to get overkill mode to work properly. So it's like I'm just gonna stick to my Cinebench and maybe some SuperPi. If I'm feeling brave, if I feel like running something complicated, I'll do a SuperPi. And mostly I want to stick to 3D Mark Firestrike and like 3D Marks, like modern 3D benchmarks primarily. But yeah, so this is so there are some adjustments, like some software tweaking that goes into this benchmark, but also it's just very stressful as far as CPU benchmarks go. Takes advantage of AVX and AVX2, and unlike, say, Cinebench, it's not AVX2 in name only, because Cinebench R20, yeah, it might use AVX2 instructions, but it doesn't use enough of them to justifiably increase the power consumption significantly relative to the non-AVX version of Cinebench, so fun fact. Yeah, that is not the case with X265. This is actually a very heavy benchmark, and in fact, you can use on like lower. Well, you can to some extent use this basically as a stress test. So yeah, that's X265, and so OGS posted an 11900K based world, like top score for the 8-core CPUs, and then Splav responded with the 6.025 gigahertz Ryzen 7 5800X backup score that he had. Because previously Splav already had the record for 8-core X265 4K, and then OGS beat him, and so Splav posted the even higher score that he already had saved, which is a very common thing for a lot of benchmark rankings, is when you post a score, like if you beat somebody else's record by a very small margin, there's a very good chance that they actually kept their personal best to themselves, so that if somebody beats them by a small margin, they can just post an even higher score without actually having to go and redo the session. So and this is especially true of Splav. Like the number, he kind of does this a lot. And so, if you're going to beat one of Splav's top scores, you probably want to beat it by a very large margin. Because otherwise, within a couple hours, he's going to post a better score. Yeah. So anyway, also it's just interesting to see the insane like performance per clock difference in X265 here, right? Like this is an 8-core video encoding benchmark, and yeah, the 5800X at 6 gigahertz like outperforms a 6.6 gigahertz 11900K. So that's kind of insane. Now, obviously, there are other benchmarks that actually I'm not sure. I think I'm actually, now that I think of it, I think all of the benchmarks, the 11900K wins outright. It only wins them because it has a huge clock speed advantage over the 5800X. And even here, it has a huge clock speed advantage, but it's not enough to offset the like architectural differences. I really wonder what it would be with X265 that does it, because technically, so X265 being an AVX accelerated, multi-core workload, it loves memory bandwidth, and that's why here on the 11900K, which doesn't have a bunch of weird cold issues with the memory controller, we're looking at 5100 CL16, which is actually a relatively, like, it's not tame, but it's not the insanity type memory overclocks that you see for some of the other benchmarks, which don't need as much memory and tolerate far greater amounts of instability compared to X265. Like, this is still a, high memory bandwidth Samsung BDI tune here in terms of the memory timings. And so this is a really memory bandwidth intensive benchmark, and yet the 5800X is just, doing a better job of it with a lot less memory bandwidth. So I'm going to assume that it's probably the massive piles of L3 cache that the 5800X comes with that make it possible for it to, outperform a 11900K that's clocked basically 10% higher. And it isn't a very large margin, in terms of the performance gap between them, but yeah, like you'd really think like this has way more memory bandwidth available, the clock speed is insanely high, and it's still slightly slower. So yeah, still though, a very, very impressive score from OGS for X265 4K. Like this is a hard benchmark to run, and the same is true for Splave. Like this is by far the highest clocked 5800X in the X265 4K rankings. In fact, if you look at these rankings, most people have more luck running an 11900K at around 6.6 gigahertz than trying to push a 5800X to 6. Right? Like the next fastest 5800X is from Miller down here at 5.9 gigahertz. So yeah, Splave is doing a really, really good job of defending the 5800X's title as best X265 4K 8-core CPU, as there's like 5 11900Ks between his score and the next 5800X, which is, like you wouldn't expect to see something like that. It normally tends to be a lot of benchmarks. You either have like all the top scores are dominated by either one or the other. You don't get this sort of weird mix where it's like, yeah, technically the 5800X, if you really dial it in, is best. But the 11900K is probably a bit easier to actually get up to, well, to get up to these speeds compared to like 5.8, 5.9 on 5800Xs. Yeah, so this is an interesting benchmark, and very impressive scores from both Splave and OGS. Though I imagine OGS aren't thrilled about the fact that Splave just kind of posted a backup score within a couple of hours of them posting their top score. But still, like second place, like this is a hard benchmark, and second place in it is still a very, very good result. So congratulations to OGS and Splave on the 8-core X265 4K scores. Let's move on to the next score, which is AKM's 3D Marco 3 triple GPU second place. So 3D Marco 3, again, everything I wanted to say about the benchmark I already said, except with 3 GPUs, there's a lot more CPU overhead, and you end up with much lower scores as a result of that. Though, funnily enough, I think for a while, the world record in 3D Marco 3 was held by like triple GPU set. Like when it first came out, it was like quad GPU was the best for 3D Marco 3. And then it was like triple GPU because the overhead from quad GPU started to be too much. And then you went down to dual GPU. And these days, it's single GPU, right? With the 3090, you have so much GPU power packed into just one card that there's no reason to run the crazy triple GPU setups. But that doesn't change the fact that the triple GPU rankings for 3D Mark 03 are extremely competitive and dominated by 7970s. And you'll also see some 290Xs mixed in, but they're not really like super common because 295X2s are, well, more awkward to run than the air-cooled 7990s. And the thing is, the real problem with running triple GPU setups, especially these days, is that you can't really get motherboard. Like for Z590, there's not really any motherboards that properly support triple GPU. The only way you're getting 3 cards to run together properly is if you have a 7990 and a 7970, or a 7990 and a 280X, or like any 79, like, you know, any dual GPU AMD card plus whatever single core equivalent that card has. And 7990s and 7970s are just far easier to get than 295X2s. Especially since you don't even need 7970s. You can use 280Xs, you can use literally anything with a Tahiti core will quite happily run 3-way crossfire with a 7990. And that's really, like, you really need that when, you know, most modern motherboards only have 2 X8 PCIe slots connected to the CPU. So that's what's going on with the GPU configuration over here. And then in terms of the settings, we're looking at, you know, CPU doing just under 6.9 gigahertz, 4 cores, 4 threads again, because of course, frame rates in the 3000s for the first 2 tests, and then just, you know, around 2,500 for the other 2 tests in the benchmark. So still thousands of frames per second. Memory doing 4800 CL14, so a more memory bandwidth tune than latency. And I do wonder if that is actually, like, if that changes based on how many GPUs you have, or if this is just like OGS recently figured out that, hey, this actually prefers latency. And so, because the thing is, the way the Intel 11th gen memory controllers behave on liquid nitrogen and at ambient is very, very different. At ambient, you know, you're not going to be hitting the kinds of speeds in Gear 1 that you will be on liquid nitrogen. And Gear 1 at ambient actually really kind of sucks in terms of the kinds of memory speeds that you can hit. And so, sure, you can get pretty low latencies, but it's still not going to be on the same level that if you were on liquid nitrogen. And so, if you were pre-testing at ambient, I think it might potentially end up that like Gear 2 works out better, because the Gear 2, I don't believe like I've seen some people running like Gear 2 over 5000 CL15 on air, like ambient cooling. So that makes it like, so I do wonder about that. Or maybe the memory just doesn't matter enough that like this is just kind of like they left over like a SuperPi 32M memory tune that they just kind of left on there because changing the memory settings wasn't worth it. But yeah, I do wonder about that. And then the 7970s, what I find very interesting there is the memory is actually being pushed quite far, 1700. I mean, it's not super far. You know, there's plenty of 7970s that will do like 1800 plus. And then 1125 on the cores, which is actually really low. Especially if you have a water-cooled 7990, like an air-cooled 7990, you can easily do like 1180 on the cores. Or at least, like, 1150 is easy, and then a lot of cards should be hitting up to around 1180. But there's maybe a chance that the 7970 Dual X over here is actually really, really bad. So, fun fact about 7970s, some of the late production 7970 gigahertz editions suck. They are so bad. Like, cards where you will be struggling to get 1160 core out of them on air cooling because they don't scale with voltage. And I'm not sure how like 3D Mark 03 actually, like heavy 3D Mark 03 is on the GPUs, but yeah, like that's potentially limiting the GPU core clocks here. And I bring that up because in the triple GPU 3D Mark 03 rankings, like OGS has the top score with slightly higher core clock on the 7970s, same memory clock, so that's probably not making too much of a difference. I do wonder if AKM like tweak the memory timings on the GPUs, because on 7970s that is quite easy to do. And then also OGS, because the thing is, OGS does not have like a huge CPU clock speed advantage, and then the memory settings are, the memory is going quite a bit faster. But the biggest difference between these two setups is actually the GPU core clock. So, maybe there's some weird software thing going on that I'm not aware of, but I'm not sure why, I'd love to know why AKM's score is like so much lower than OGS's score. I know, if I had to guess, it's the GPU core clock. In which case, I don't know why you wouldn't run the cards above 1125 unless your like air-cooled 7970 was absolutely terrible, which is certainly possible. It's just, like 7970s aren't that rare, so you'd think you'd source a better one. At least pre-GPU shortage, they weren't really that rare. Yeah, 7990s generally have pretty good silicon quality. They just don't have very good cooling. But, on water cooling, that's not an issue. So, yeah, and still an impressive score from AKM, though. I mean, you do still need to run that 11900K on liquid nitrogen. And so, congratulations to... And then... Well, Crossfire in my experience is actually very easy to enable. It'll just kind of run on basically anything. It'll run through chipsets, it'll run on X4 PCIe slots. It just kind of, unlike SLI, it works. Admittedly, in games it doesn't, but in benchmarks it works. It works really well for benchmarks, and in the real world it's completely bloody useless in my experience, but yeah, as far as like the various benchmarks are concerned, Crossfire is super super reliable. It'll enable on basically anything, which can't be said of SLI. So yeah, I know. So I wish I knew more about 3D Mark 03 because it makes it really hard for me to judge these scores when it's in a benchmark that I've literally never run, and especially a benchmark as wacky as 03, right? Where we have like on the literally the world record is like almost 2.9 gigahertz 3090, and then in the triple GPU setups we have like not really that heavily overclocked 7970s. I think there's been 7970s on LN2 in triple setups on 3D Mark 03 in the past. Yeah, there has. Like, people have run 3D Mark on 03 on 7970s on LN2. What a weird benchmark. Like, this is certainly, like, I feel like this is a benchmark that... How very interesting. Yeah, like, imagine juggling that many LN2 pots. Though they aren't really pushing well, 14... Nah, that's not really that hard. At least... Yeah, that really shouldn't be... It's not... You're not really pushing those 7970s that hard for that. Now, maybe in triple... The thing is, my experience with Crossfire is that, like, if you have a card that does 1200 solo, and then you just need to find another card that does 1200 solo, you put them together, and they still do 1200. I've heard that with NVIDIA, normally multi-GPU setups, like, start losing clocks, but, like, I've run quad GPU AMD setups where they hit the exact same clock speeds that each card does individually. And in fact, Crossfire will even let you run all of the cards at different clocks if you're inclined to do so. So yeah, but still, like, it's not like 1406 is not so low clock that, like, you could really, like, that's like chilled water cooling with a lot of voltage on good cards. Yeah, for liquid nitrogen, 1406 is, I'd say, kind of taking it easy on 7970s, unless one of them is really terrible. But, like, I have a really bad 7970, and even that does, like, 1450 on liquid nitrogen. So, yeah. 3D Mark 03, a wacky benchmark, and congratulations to AKM on the triple GPU second place, because I wish I could say how hard this is to run, but I don't do 3D Mark 03, so I'm not sure, but it is a very interesting benchmark in terms of the, like, setups that you see for it. So yeah, anyway, let's move on to the next score, which is Miller's Cinebench R20, dual-core Cinebench R20 top score with the Core i3 7350K at 6.65 gigahertz, which doesn't really sound like a very high clock speed, but 7350Ks, fun fact, are not cut down 7700Ks. And for whatever reason, 7350Ks basically universally suck. They have a terrible memory controller, and they like the liquid nitrogen clock scaling is a lot worse than on 7700Ks. Like with a 7700K, 6.6 gigahertz is like an average CPU. With a 7350K, 6.65 is insanely good. Like, this is an insane clock speed for a 7350K to be running. Also, these chips are very fiddly to run, because you do have to deal with like the thermal paste under this, because yeah, you have to deal with thermal paste cracking issues. The 7350Ks also have different voltage preferences for running at full pot compared to 7700Ks, or at least my one does. So I'm not sure if that's universal. Maybe there's some 7350Ks that behave more like 7700Ks, but yeah, and then the memory controllers also aren't great. So, we're looking at 4200 CL14, which for a 7700K, that would be kind of like, whatever. For a 7350K, that's actually impressive because these are not like the same CPUs as 7700Ks whatsoever. And yeah, so just a, like an insanely good 7350K here from Miller, running on a Z170 MOC formula, which is just literally the best, or no, I'd say the best extreme overclocking Z170 motherboard. And what's really cool about this board is ASRock, instead of producing a Z270 OC formula or a Z370 OC formula or a Z390 OC formula, ASRock instead would just put out BIOS updates for the Z170 OC formula, which I actually find really frustrating because if you weren't one of the people to buy the Z170 MOC formula when it was first available, you couldn't have an extreme overclocking ASRock board for a 9900K because ASRock was just constantly putting out BIOS updates for the Z170 to run steadily, because if Intel hadn't changed the socket from 1151 to 1200, I'm pretty sure ASRock would have put out a BIOS update to run even a 10900K on this board, because that's basically what they were doing. So that makes the Z170 OC formula kind of the longest lived. Well, actually, you can do this with a bunch of Z270 and Z170 boards, but the thing is, with ASRock, this was not official ASRock BIOSes, but they were BIOSes produced by ASRock to add support, or at least by engineers at ASRock to add support for not officially supported CPUs onto the board. The board did require some modifications to get a 9900K to run, but aside from the BIOS, but yeah, really cool just that this board got supported for so long with such a large variety of CPUs. And yeah, also this LN2 pod is so cool. So this right here is a super full pot optimized LN2 pot design, and I believe it's also a direct die contact LN2 pot. So I don't actually have one. I've never run direct die on LN2 myself. I've tried it, and it just, well, I didn't try it on the ideal motherboard, so maybe I should revisit that. But yeah, this is one of the, at least for KB-like CPUs, direct die, this is probably the best LN2 pot for doing that. So yeah, that's quite the LN2 pot that Miller is using right there. And now Miller posted this score because Noisemaker beat his previous top score. So yeah, we have a similar situation to what happened with Splav's X2654K benchmark. And in fact, Miller is even making a joke about it down here with found on Splav's USB. That's not actual, that's a joke. Okay, don't read into that too much. It's literally just a joke about how, because Splav on some of his scores, he didn't do it on this one, but on some of his scores, Splav basically has a comment just saying found on my USB stick. Yeah, so this is basically just a reference to that. And yeah, so Miller basically just responded to Noisemakers 7350K top score, and by a very small margin. In fact, the fact that Miller has the score by 1 point, even though the clock speed difference is so big, you know, like this, the thing is, go away. Anyway, I hate drop downs on a website. Yeah, anyway, the thing is, this clock speed difference here is actually really large for Cinebench, because Cinebench is basically just a pure CPU frequency test. And so it's very strange that Miller's score isn't higher, because if we pull up the calculator, on paper, Miller's score should be about 0.4% higher. In other words, it shouldn't be, you know, it shouldn't be 1832, it should be like 1838. So I would not be surprised if Miller has an even higher score still lying around somewhere on a USB stick. Yeah, still a very, like, this is still an insane score for a 7350K, mostly because of the frequency. Like, that is just a very high frequency for a 7350K to reach, and it's even harder to actually hit this kind of frequency in Cinebench R20 compared to Cinebench R15, because R20 takes forever when you only have 2 cores. Sure, those cores might be doing 6.6 gigahertz, but that doesn't change the fact that there is only 2 of them, and this is a lot of stuff to render. So yeah, a very impressive score from Miller here, and also from Noisemaker, right? Like 1831 at 6.625 gigahertz, running on a Z270 Apex, literally the best Z270 extreme overclocking motherboard. Not that there was much competition for that either. Right, it's not really until Z590 that we got like a flood of proper extreme overclocking motherboards from the various manufacturers, but still, like this is also a very impressive score. Similar memory settings, because the thing is, Cinebench R20, it does care about, so with AMD CPUs, it basically doesn't care about memory settings at all. With Intel CPUs, it cares somewhat more, because especially like a 7350K just doesn't really have that much L3 cache, and so the benchmark's going to be accessing the memory a lot more frequently than on something like a 5800X, which has 32 megabytes for its 8 cores. So, yeah, and then we've got, you know, G-Skill, Samsung BDI memory. Like, the thing is, this is not memory limited. This is just like the memory controller was probably not very cooperative when trying to push the settings any higher. And I guess this is kind of, this is what it looks like when you tune a 7350K for memory bandwidth, because again, the high frequency on those CPUs is not really a thing that they do. The cache still clocks very high because the ring is very, very small. In fact, I think the core clock to cache clock gap is probably one of the smallest, because the larger the ring gets, the more the max clock speed of the ring suffers. So yeah, here we're actually Miller's chip, I think, is only like, yeah, it's not even, it's like 200 megahertz of clock speed difference between the cores and the cache, which is very, very small compared to what you see on some of the like larger CPUs, where you might have like a half a gigahertz gap between the core clock and the cache clock, just because the ring is so much larger. So yeah, anyway, 7350Ks are just like really like, I wish these CPUs were more popular when they were available for retail, because these would be really interesting as just sort of like cheap CPUs to bench on LN2, except they weren't popular because they weren't cost effective at all when they released, right? Like, they were a real sort of like overclocker focused oddity of a CPU that didn't really make a lot of sense in terms of actual in terms of performance per dollar for regular users. So yeah, that's a bit of a shame that like these aren't more common because of that, especially since the silicon quality on them is kind of all over the place. I mean, let's just take a look at the Cinebench R20 rankings here. You know, you see chips going all the way from like 6.2 to 6.65, and that is actually a pretty like reasonable stopping point for some 7350Ks around the 6.3 gigahertz mark. So Yeah, like chips doing 6.65 for Cinebench R20, that's insane for a 7350K. So yeah, congratulations to Noisemaker and Miller on the very impressive dual-core Cinebench R20 scores, and let's move on to the next score, which is Obi-Wan83's GPUPi for CPU 1 billion, single-core, third place. Running an Intel Xeon L3014 at 5.6 gigahertz for 36 minutes on a cascade phase change cooling system. So yeah, quite the cascade there. I'd like to know what temperature it was sitting at, but I guess minus 100 based on that. I'm guessing, yeah, that looks like that's the temperature probe for the actual head, so minus 100-ish. So that's a pretty, that's a cold cascade. I do believe I've heard of cascades that go lower, but they get steadily more and more ridiculously sized as you need more and more stages or just bigger cooling stages to achieve those lower temperatures. So the Xeon L3014 is an interesting CPU because it is the fastest single-core chip for basically the vast majority of single-core, like vast majority of benchmarks. The other CPU that can sometimes kind of compete with it is the Sempron 145. You might think like, but why isn't something, more modern faster? Well, it's like, sure, a Sandy Bridge chip might have way more IPC, but it's literally clocked at less than half the, like you'd need an IPC that's literally like times 2 of what the L3014 does in order to make up that clock speed difference of 5.6 gigahertz compared to like 2.2 on a single core Sandy Bridge. So yeah, single core benchmarking is kind of interesting, is that there's basically 2 CPUs that are good at it. One of them is the L3014. Evidently for GPUPi, it is significantly better than the Sempron 145, as we do not see any Sempron 145s anywhere in this ranking, at least in the top end of it. Actually, are there any Sempron 145s in this? Anywhere? Yeah, so, there's also the Sempron 150. I guess that's a better option than a 145. Yeah, but that's an hour on single stage. So the thing is, the Sempron actually has even less IPC, right? Like a lot less, as it takes an hour and 4 minutes. But anyway, so the L3014 Xeon is also interesting because it's not actually it's an LGA 771 CPU, but it can be modified to run on LGA 775 motherboards, which is what we're seeing here, as this is running on a P5E64WS Evolution board, which uses an X48 chipset. So, yeah, that's just fun fact about the weird things you can do with old Intel CPUs, or more like old Intel 771 Xeons, is you can actually run them on LGA 775 boards. For the memory, we're looking at 1866 797, which isn't really that aggressive by DDR3 memory standards, not even for LGA 775 as far as I'm aware. But, if you're running a benchmark for 36 minutes, and I don't believe GPUPi is particularly, like, memory sensitive, and if you have one core, I can't... Like, if anything, having a single core CPU probably makes it even more insensitive to memory, because it's just, like, the chip is so damn slow that you're not going to be bottlenecked on memory. Like, the chip is probably so damn slow that you're not going to be regularly, bottlenecked on the memory access. And so, you don't really, if you're running a benchmark for 36 minutes, the last thing you want is it crashing because you pushed the memory a little bit too far for marginal performance gains. So, yeah, a very, committed run from Obi-Wan here, and just an impressive score. Now, what's even more insane is the actual world record for a single-core GPUPi is from Lumi, and that was done with liquid nitrogen for 34 minutes. So, yeah, I can't imagine that was very fun to do. Yeah, this is I complain about SuperPi on older CPUs taking 7 minutes, and there's people running freaking Xeon L3014s for over half an hour on liquid nitrogen. Wonder if Noxonite did the same. Apparently, yes. I hope, like, at least being a single core, it probably doesn't use that much liquid nitrogen. Oh, and this is with the North Bridge on LN2 as well. So, yeah, the L3014 is a rather interesting CPU, and unfortunately, I'm actually not sure if it's particularly rare, but it might be because I'm guessing, like, so the kind of annoying thing with a lot of the super old low-end CPUs is that they have such low retail, like the value of them is so low that they're probably all just recycled at this point, or at least a lot of them are recycled at this point. So finding an L3014 is probably pretty difficult, but still. And then also you probably want to bin them a bit to try find one that's actually, you know, good in terms of the frequencies it can hit. But yeah, a crazy score from Obi-Wan83 here for the L3014. Running GPUPi on one core for 36 freaking minutes, as well as 26 seconds and 215 milliseconds. But, you know, I don't think the second part of this really is much of a concern when you're sitting there waiting for the benchmark to finish for over half an hour. So, yeah, congratulations to him on that, and let's move on to the next score, which is Kepi 1475's Cinebench R20 top score for the Ryzen 5 3600, pushing the 3600 all the way to 5.75 gigahertz, which is really, really high. Like, Kepi just absolutely rewrote what it means to be, you know, to run a 3600 on liquid nitrogen. As previously, the top score for the 3600 was held by Unity of Saints at 5.4 gigahertz, and I felt pretty good about my second place at 5.275. I need to rerun that chip because I'm pretty sure I wonder if Unity, like, how, I'm not sure. Did he mention what batch this chip is? Because the thing is, with the Ryzen 5 3600, there's a pretty big jump in silicon quality going from, like, the early batches to the later batches. And I do have a later batch chip. Mine is not particularly amazing, but it like I've heard of some 3600s that are absolutely ridiculous that were, like, late production 3600s. And actually, AMD's probably still producing 3600s. I wonder how those are. They're probably pretty good. So yeah, but Kepi 1475 has just, you know, 5.75 gigahertz, so 350 megahertz above Unity of Saints, and making me look like an absolute pleb, with my not even 5.3. So yeah, I need to put more effort into that. The thing is, I never got my chip to run at full pot. And I also wasn't super committed to the run. I was just kind of like, if I can get second place, I'll be fine with it. Now I got to go fix that eventually. But yeah, so just like a crazy high frequency out of the 3600. And also this why stop using 4K monitors, people? What is wrong with you? Can't see your settings. So Cinebench, not much of a memory benchmark. So Gear 2. So the thing is with the 3600, the main problem I ran into was that the memory overclocking just gets so broken. And also getting the chip to full pot requires very low, or to work at low temperatures requires very low infinity fabric clocks. And so this right here, this is 2-to-1 mode on the memory, but with the memory running like 2800. Isn't it? Yeah, that's DDR4 2800. So, man, the Infinity Fabric might be at like 700 megahertz, which doesn't really affect Cinebench because, well, it's freaking Cinebench. It doesn't really access the memory much at all. Even Ryzen 3000 already did this, where you didn't really, like, Cinebench doesn't care about memory settings basically at all. And the 3600, if I remember correctly, it has 32 megabytes of L3 cache, so that isn't particularly surprising, because the more cache you have, the less you need to worry about memory performance. That's kind of the main reason why AMD throws so much freaking cache at their CPUs. It's like, well, with the way those chips are structured, the I/O die adds a bunch of memory latency. Well, we can hide most of that if we just don't access the memory in the first place by having tons of cache. So yeah, like just sort of really dialing in the 3600 here to get that frequency so high, right? Because the thing is, the colder you can run the chip, the more you can raise the voltage. And also these chips scale more from temperature than they do from voltage. So like the frequency increase you get from just lowering the temperature at, say, like let's say you set the core voltage to 1.4 volts and you go from like 70 degrees Celsius down to minus 70 degrees. That actually makes way more of a difference to the clock you can hit than raising the voltage another 200 millivolts once you're at minus 70 degrees Celsius. In fact, that'll probably not do you much. Well, at minus 70, you're probably going to be still see some gains. But the thing is, if you keep raising the voltage too far, you actually start getting negative scaling as the internal chip temperatures start to go up, right? You are thermally limited, first of all, rather than voltage limited. And so the key to getting insanely high clocks out of Ryzen chips is to figure out how to get them to work at extremely low temperatures. And so I'm assuming that's why we're looking at these memory settings over here that, like look absolutely like this looks horrendous. But it's like, hey, if that's what it takes to do 5.75 gigahertz for Cinebench, totally worth it. Totally worth it. Also, an interesting choice of motherboard, the B550 Steel Legend. Definitely a great cost-effective overclocking motherboard. Like, I wasn't so impressed with this board until I tried out some of the, like, and did he pull off his 8-pin power Yeah, I think he tried to pull his power connector off while the board was still frozen and the 8-pin plastic came with it. Oh well, that's like the board will probably be fine. Like that doesn't like you could still plug that in, right? Like the way those like the plastic casing is more there to prevent you from plugging in the connector backwards than for ensuring contact between the pins and the sockets in the actual power supply end of that connector. Or cable end of that connector. But yeah, the B550 Steel Legend, like, it's actually, like, for the price, it's actually a really solid overclocking board. You have sort of all of the voltage settings you would want. You have all of the voltage range you would want. It has a post code, which is a lot more than you get from most other motherboards at this price point. And then for a 3600, the VRM on this is actually very, very overkill. The only thing you could really complain about with a B550 Steel Legend is that it does only have a 4-layer PCB, but that doesn't really matter that much if you were running a Ryzen 5 3600. And it also, you don't need memory clocks when you're on liquid nitrogen because the memory controller doesn't work anyway. And also this is Cinebench. So yeah, like just a cool choice of motherboard, right? You don't need like depending on what benchmarks you're running, you don't really need a crazy motherboard to get top scores. Phenom LN2 pot, this thing for a Ryzen 5 3600 is actually a good fit. I have a Phenom, not great on hot CPUs, really not great on hot CPUs, but a Ryzen 5 3600, even at 1.7, like, or 1.77 volts, like it's on liquid nitrogen. As you cool a CPU down, its power consumption plummets. And this is especially true for like the newer, really dense manufacturing processes that we're seeing, where just like, in the past this was already true, but with with the more modern processes, it seems to be amplified. The colder you can run the chip, the more if it like the performance, like the leakage reduction, I guess it's greater. I've not measured it, but like anecdotally, I have noticed that the power consumption on liquid nitrogen with a lot of modern CPUs that aren't Intel 14 nanometer, well, even those like really improve in terms of power draw. It's just that they're so damn big that they still pull a ton of power. So what I wanted to check was do we have a power reading? Oh, we don't have a power reading. Not an accurate one. Like it says 25 watts, but that's like that's just wrong. Yeah, so an impressive score. Also, Micron memory sticks. So this is sort of the extreme overclocking budget dream build. Just a very cost-effective overclocking motherboard. The Phenom pots, you can get them relatively cheap because like these days you're finding those secondhand. And unfortunately, the one downside to the Phenom is it doesn't have a proper AMD mounting bracket. But the thing is, you can just use 2 of the Intel mounting holes, and like it'll keep the LN2 pot centered over the CPU. You don't really need like you don't need a ton of mounting pressure to get a like good thermal transfer, especially since the LN2 pod itself is pretty heavy. So it'll do a pretty good job of squeezing the thermal paste with just its own mass. So yeah, a really impressive score from Kepi 1475 here. On the Ryzen 5 3600. Like, this thing is absolutely flying. I think this is like approaching the territory of the 3600Xs in terms of frequencies. Actually, it's beating them. Not on the score, which might actually be down to the Infinity Fabric and memory stuff. Might be. Yeah. I guess once the chip is going over 5 gigahertz, the memory starts to matter a bit more than normal, but though, well, I'll need to do more testing on that, I think. Luckily, the 3600 really doesn't suck up a bunch of liquid nitrogen, so yeah, on a well-insulated motherboard, you could easily spend a lot of time just, dialing in one of these CPUs, and it wouldn't really like burn through the liquid nitrogen insanely quickly like some of the high power draw stuff that is available. Which just like there's CPUs where even idle is just using a concerning amount of liquid nitrogen, and then when you go to run the benchmark, it's just so much worse. Yeah, so like honestly, late production Ryzen 5 3600s might be interesting to revisit for competitive benchmarking. Like, it's beating 3600 XTs. Just like outright, like A on clock speed, but B on the score as well. So yeah, great score from Kepi 1475 here. Just, yeah, like literally, I think this is, so technically the fastest 6-core Ryzen 3000 series CPU, and congratulations to him on that, because, yeah, like the 3600 hasn't really gotten that much attention, but it really deserves it, I think. Right? Wait, I'm not misreading it. Yeah, no, I'm not misreading it. Like, literally second place in the 6-core Ryzen 3000 series ranking. So, yeah, congratulations to Kepi 1475 on, that Ryzen 5 3600 overclock. Because these are fiddly CPUs to run, like you do need to take time to dial them in. And so, yeah, I'm impressed, which is the point of the HWbot score roundups. Let's move on to the next score, which is not that, it's this. Bones SuperPi 32 million, 11 minutes, 51 seconds on a Phenom II X3720 Black Edition doing 6.0, a little over 6 gigahertz. So 720 Black Editions. I actually have like 2 or 3 of these chips. I hate them because the thing I love about Phenom 2s is that later production Phenom 2s are super easy to run on liquid nitrogen. However, all of the 720 Black Editions are made on the original stepping of the Phenom 2 CPUs, and they freaking suck. Okay, it's not quite that bad, but the memory controller is horrendous on liquid nitrogen, and so 32M being a very memory-intensive benchmark, what the hell? That's actually like good memory settings. Yeah, okay, like Bones really, like, I don't know what he did, but that right there is black magic. You're not allowed to run over 1300 on LN2 with a freaking 720. How did Unity of Saints run? Yeah, like this is what I'd expect from a freaking X3 720. Like 720 Black Editions, you get stuck at like 1400, 1500 on your memory, which does mean you can run, the timings super low, but your timings are measured in clock cycles. So if your clock cycles are really long because your frequency's really low, your timings aren't actually that great. So Yeah, and like Bones really demonstrates that because he's running still 666, but at 836 megahertz instead of at 736 megahertz. Also more CPU clock. So um, yeah, Bones has really like I don't know if he just like binned his way to a 720 Black Edition that just doesn't suck, or if there's some black magic that he's figured out to get these chips to run on liquid nitrogen a lot better than they normally do, because like my experience with these CPUs is that they are incredibly frustrating. Um, and also they have cold bugs, which is unique to like well actually a lot of the early stepping. Wait a minute, stepping 2. Wait a minute. Also 2. Okay, no, it's not C1 that really sucks. It's already like well, or am I just misremembering? I need to check mine. Okay, I guess they're all C2. Like, I need to check my 720 Black Editions. But either way, like, these CPUs are and like, they are nothing like any of the other like, nothing like the other Phenom 2s in terms of how they behave. Um, Quite fiddly to run, and, yeah, so this right here from Bones is just very impressive, right? Running over 6 gigahertz, 2 cores, 2 threads. I do wonder... okay, I'm not seeing PS check on his desktop. So the fun fact about Phenom 2s is you can actually clock them per core, um, which works for SuperPi pretty well in my experience. It doesn't work great for multi-threaded stuff, but for SuperPi, I think it should work just fine. So I thought that might be going on here, but maybe not. Maybe this is actually both cores running all the way at 6 gigahertz. Either way, still a very, very impressive like overclock for a 720 Black Edition, especially on the memory, because freaking memory controller on those things is like it does not like being cold. It really doesn't like being cold. Um, Also, interesting choice of motherboard, a Sabertooth 990FX R3.0. Pretty rare motherboard. This is like the last 990FX motherboard to be released. Yeah, it is a motherboard that I've kind of wanted to get my hands on just to take a look at it. Like, what was the final iteration of the 990FX chipset from Asus? Because I think this was the very last 990FX board that got released from at least like a major manufacturer. Um, yeah, but that's also like this is the thing I love about AM3 Plus as a extreme overclocking platform is just you have such a variety. Like you can have one good motherboard, and the variety of CPUs you can shove into it is just so big. You can run horrible things like the 720 Black Edition, and you can also run horrible things like the FX9590. There's also good CPUs like the 1100T, 965 Black Editions, 975 Black Editions, 980s, like, all the different Phenom 2s, especially like the various 900 series Phenom 2s, the 1000 series Phenom 2s, Athlons, Semprons, like, such a variety of chips that you can shove into an AM3 Plus board, and that makes AM3 Plus one of my favorite extreme overclocking platforms because you have, like, it's kind of like LGA 775, except the thing is, I'm not sure how, I don't know how it is with LGA 775 on liquid nitrogen, but with AM3 Plus, a lot of the CPUs that you can stick into the socket work really well on liquid nitrogen. The 720 Black Edition, however, is not one of those. At least not in my experience. So, yeah, a very impressive overclock from Bones here with the 720 Black Edition. And let's move on. So congratulations to him on that. And let's move on to the next score, which is Mikulti's 3D Mark 05 top score for the Intel HD Graphics 4600. So we've got some iGPU benching going on here. And Mikulti actually does Twitch live streams of his overclocking sessions, so I may or may not remember to leave a comment in the description with a link to his Twitch. But yeah, this was actually live. I think this was live streamed. Yeah, this was live streamed. I remember catching a bit of it, not all of it, a bit of it. But yeah. Anyway, we've got so 4790K, because that's the CPU that comes with the HD 4600 graphics. I guess there might be some other CPUs that come with that same iGPU, but The other ones probably aren't overclockable if, because it's Intel. Z97X SoC Force motherboard. So this is a T topology motherboard, and so we're looking at 4 memory sticks. Single rank memory sticks. Each of them is one of these lovely things. This is what peak DDR3 performance looks like. These horrible OEM green PCBs from Samsung. Because the thing is, these come with a very unique little memory chip. And it is actually little, like this is not a very large DDR3 memory chip. These use Samsung 1 gigabit G-Die. And G-Die is cool because it does things like 2933 CL10, 1314 with TRS-22, and actually TRFC, you can lower the TRFC a lot more than that. It's just, I believe Mikolti actually tested the TRFC and it just didn't scale. So it's like, why, add potential for instability for a timing that doesn't actually make a difference in performance at 1T command rate. Like these DIMMs, super easy to clock super high. Now, for whatever reason, the HD 4600 graphics apparently aren't really super memory bandwidth bound, so the priority here was actually tightening it up all the sub timings, not so much maxing out the frequency, though G-Die is very, very good at that. In fact, my personal best for DDR3 frequency is on a random stick of Samsung G-Die. It's like DDR3 3500, so yeah, super easy to do on like I just kind of did it for fun while running a LN2 session on a FX9590, I think it was at the time. But yeah, so G-Die is a like if you're into if you want to get into competitive DDR3 overclocking, it can't hurt to get yourself a set of this stuff. Maybe multiple sets. Maybe buy like 50 sticks of it. It's really freaking cheap because these are 1 gig DIMMs. Nobody, no regular people don't buy 1 gig DDR3 sticks because they're too small. But that's where they're wrong. The size, these sticks clock way higher than everything else. And so it might, as long as the benchmark fits into the memory, who cares? So yeah, that's what's going on with the memory here. 4790K at just 5 gigahertz. I don't believe 3D Mark 03 is particularly CPU bottlenecked when running on the iGPU. It's running at like 124 FPS, 84 FPS, and 120 FPS. So the 5 gigahertz 4790K is more than enough for that. Phase change cooling system, right? That's what we're looking at there. And yeah, just a all-round pretty impressive score for the HD 4600 graphics. There's quite a bit of competition on the iGPU because, hey, if you've got a 4790K, it came with a free HD 4600 iGPU built in. May as well bench it. So, yeah, that makes these pretty interesting. And actually, I wonder what some of the other top scores, because I'm going to guess this is probably like your standard, not PSC. So this is Samsung D-Die, but that, as you can see, is just doing 2666 CL9. And that is going to be a dual rank configuration as well, because we've got 2 8 gig DIMMs of that. So that's these sticks are actually so 2 gigabit D-Die is actually a pretty good competitive DDR3 memory chip. Unfortunately, because it's actually in a useful capacity, it's also way more expensive compared to G-Die, which is sort of what makes G-Die really, really awesome if you want to get into competitive DDR3 overclocking. Is it's dirt cheap because it's super tiny. Right? Whereas 4 gig DIMMs, those still cost a reasonable amount of money, but 1 gig DIMMs, nobody wants those. So that gives G-Die, makes G-Die really easy to get. Yeah, and here we see more D-Die doing 9-12-12 at 2700. Also in a dual rank configuration, because the thing is, on DDR3, actually, dual rank is the standard. You don't really want to be running single rank on DDR3 whatsoever, because one, DDR3 doesn't clock high enough to have as much of a penalty for dual rank versus single rank, and two, well, because there's not that much of a penalty, you just really want to be in dual rank. Yeah, and then Noxonite's actually running a quad rank setup for this. Yeah. So this is actually dual rank G-die sticks hanging out there, doing 2860, like 2870-ish, 9, 12, 13. So actually that sounds a bit more impressive than the 2966, no, 2933, 10, 13, 14. But yeah, it's just like the amount of like G-Die is super flexible. Like if you're gonna get into competitive DDR3 overclocking, get yourself some freaking G-Die. It's cheap. It does things that other memory ICs could only dream of ever doing, and well, what more could you ask for, really, right? From a overclocking memory chip. Like, it's a real shame that on DDR4 we don't have some like low capacity memory chip that is capable of competing with Samsung B-Die, because Samsung B-Die is unfortunately like a useful size. Imagine if like 4 gig DDR4 sticks were actually like amazing at overclocking. It would be so much cheaper to get like top scores in like memory benchmarks. But no, we're stuck running 8 gig memory chips or 16 gigabit memory chips. And it's just like, yeah, but DDR3, you know, all the cool chips are small. And that's actually true. Like the other good memory chips are like there's 1 gigabit PSC. Memory chips are really, really capable. So you have 1 gigabit G-Die, 1 gigabit PSC, 1 gigabit LPDA. So that would be like what Bones was running here. This is probably LPDA Hyper. And you have 2 dual rank sticks of that for 4 gigabytes in total, because you know each stick is going to be 2 gigs with 1 gigabit chips. So yeah. Anyway, cool score from McCulty on the Intel HD Graphics 4600 3D Mark 05. So congratulations to him on that, and spread, you know, get some G-Die if you want to bench DDR3, because it's totally worth it. It costs nothing compared to some of the other memory chips that you could potentially be like searching for to use on DDR3 platforms. Anyway, let's move on to the next score, which is Salty Croissant's 3D Mark Firestrike Ultra on the GeForce GTX 680. So Salty Croissant has expanded into not just chilling his actually he's been modding them. He's been modding GPUs for a while, but we're starting to see more and more cap mods on his cards these days. So progress, and also the like if you're gonna do a power bridge, do it with wires that, you know, have some like thickness to them. Because this right here is just I don't I don't think those actually achieve anything. I've in my experience, if you're building power bridges, like even 18 gauge cables don't really do a great job. And so this right here is kind of like, I'm pretty sure this is a whole lot of effort for not a lot of gain. However, the capacitor selection and the application of capacitors I do approve of, right? We've got a bunch of stacked molded polymer capacitors just sort of all over the place. It kind of looks like we have some multi-layer ceramics getting stacked as well. Actually, yeah, he fully populated the multi-layer ceramics behind the VRM. You can see a few of them are not quite correctly lined up, but that's fine. Hey, as long as the capacitors are on there, that's like, it doesn't matter if they're if they're perfectly aligned. Volt mod for vCore, I'm guessing, and voltage read point for that as well. And so the interesting thing about running 3D Mark Firestrike Ultra on GTX 680s is that you need 4 gigs of VRAM to run Firestrike Ultra, and GTX 680s don't regularly come with 4 gigs of VRAM. So yeah, this is one, like, it kind of makes this benchmark a bit awkward, where it's like, you know, if you have 4 gigs, if you don't have 4 gigs of VRAM, like, you're just completely screwed. Right, like that, I think would be, say, this score right here, which I'm guessing is on a 2 gig card. Yeah, this is on a 2 gig card, and you can see like the benchmark is running at 2 FPS in Graphics Test 2, because Graphics Test 2 is very memory intensive, and if you don't have enough VRAM for it, you're fetching all of your GPU, instead of running through data from its own memory, is running through data from system memory. and that has to be accessed over the PCIe, which is really freaking slow, right? Like the onboard memory of the GPU, you have like almost 200 gigabytes of bandwidth, theoretical. If you're going through the PCIe, well, you have to go through the PCIe to the CPU. The CPU then needs to go grab it from the memory, then send it along to the GPU. It just takes for freaking ever, and that's why you get to render a frame every half a second, because you want to get your data for the frame. Yeah, you'll have to wait for that. So that makes 3D Mark Firestrike Ultra a kind of awkward sort of like, can you, like, basically it's like you want to run Firestrike Ultra on a 680, go find a card with 4 gigs of VRAM. So yeah, this right here, I believe is a palette card. Am I right about that? Oh no, this is an MSI Twin Frozer. That's surprising because this is a reference PCB, with the, like, NVIDIA is just so good at making VRMs that just defy all logic. It's just like, how can we make the power plane as much of a power strip as possible? You know, instead of a nice wide power plane with low power loss and low inductance and low resistance, how about we just make the power plane, like, put it sideways and make it longer, so we can lose as much power as possible before we even get into the to the core. So that's what's going on here. Also, it's a 4-phase, and if you raise the core voltage high enough on this thing, it will blow up at some point. Though you can, avoid that if you just apply a lot of air cooling, like a lot of airflow. So anyway, other than that, Salty Croissant runs a water chiller for all of his GPUs, and yeah, you can see the VRM cooling, and also just keeping the base plate on helps quite a lot. 1.4 volts to the core, which is, yeah, that's approaching the point of where these VRMs like to not work anymore properly. I think they really start failing at around like 1.45 and up. Or so I've heard. I've not tested it myself. Unfortunately, actually, I don't think I had a reference. Yeah, I've not ever had a proper reference 4-phase GTX 680. The thing is, once you, like, the 600 series and 700 series are sort of the last NVIDIA GPUs that are really fun to bench on ambient, because they're the last NVIDIA GPUs that properly scaled with core voltage. Consequently, the power consumption gets absolutely ridiculous very, very quickly, because if you increase the core voltage by 20%, well, your current draw increases by 20%, and that's before you account for the increased operating temperatures and the increased clock speeds. So, yeah, because your power draw also scales basically linearly with clock speed. So if you go from, like if you do a 20% core clock increase, that's another 20% more power draw on top of whatever you already did with the voltage. So cards that scale with voltage just hit absolutely ridiculous levels of power draw very, very quickly. Unfortunately, which, like, it's still true on liquid nitrogen, except that with modern NVIDIA GPUs, it's only really viable to do that on liquid nitrogen. Like, if you shove, like, let's say my 3060 Ti, with 1.13 volts at ambient, it would pull a ton of power, but it wouldn't really clock any better than it did at, like, almost stock voltage. So that's kind of the big difference between, like, modern NVIDIA GPUs and old NVIDIA GPUs, is on the old ones, there was a pretty good reason to actually crank the voltage up. Whereas on the modern ones, it's kind of like you're just wasting your time unless you pull the GPU temperature way down. So, yeah, an impressive score from Salty Croissant, though it also kind of comes down to just him being the first to run one of these on I believe on a water chiller. Because so far, like, yeah, like 4 gig 680s are a little bit awkward to get. Actually, this is also on this is on phase change. And this is like wait a minute, this is some Asus card. But I don't recognize that VRM layout. Why is the VRM over there? That doesn't, like this looks like a 670 PCB to me. But anyway, yeah, Salty Croissant, just congratulations to him on, pushing the card to 1463, which is a very, like, that's a lot of core clock for a 680 to be running. And then 1824 on the memory as well, which I'm actually not sure what the memory on 680s does. Yeah. I have kind of a lot of 680s. I don't bench them that much, or more like I don't remember. I didn't pay that much attention to what the memory was doing. That's the better way to put it. So yeah, congratulations to Salty Croissant on that. And the last score for this score roundup is Unity of Saints SuperPi 1M on the FX8320 at 7.9 gigahertz. And this is what makes FX CPUs so very fun. Is just like the frequencies that you can run for both validations and benchmarks. Though to be fair, SuperPi 1M is basically like this is a benchmark where a very real problem is that you're going to open up CPU-Z and the act of opening CPU-Z is going to crash the system. Like you'll finish SuperPi and then you'll go to open CPU-Z and that's going to crash the system, not the benchmark. So yeah, that's kind of like yay SuperPi 1M, but it's just cool to run CPUs at just crazy high frequencies. Like that, like I still think like with FX chips, it's mostly down to just getting lucky with a chip that actually has good silicon quality, and then you also need a motherboard that is capable of running that chip at really high voltage, which in this case we're looking at a Crosshair V Formula Z. Now the annoying thing with the Crosshair V Formula Z is it doesn't have one. Actually, this kind of looks like it might be one core per module mode. I wonder about that. So one of the big things for FX chips is having a motherboard with one core per module, because that increases the single-threaded performance of the chips quite a bit because it disables the second core in each of the modules. So you get all of the available resources. Well, you basically get the entire front end for just one of the cores, as well as the entire FPU for just one of the cores. And that gives you a slight boost to single-threaded performance at the cost of not having all the extra cores. Yeah, other than that, for the memory, we're looking at some Samsung D-Die, just kind of doing 26, 66, 11, 13, 13, 13. I'm pretty sure if he, like, FX plays well with Samsung G-Die in my experience. So that would have been interesting. Actually, wait a minute. That's, what the hell? 3.5. Oh, I guess it might be MaxMem, right? Because what is that? I don't recognize that memory. Yeah, what is that RAM? Does it say? Oh, Tridents. Wait, what? Why don't they... What? I guess he replaced the heat spreaders on them. I guess, well... I'm a really big fan of the Trident, the original Trident heat spreaders. I think those are like some of the best looking memory sticks ever made, but... Oh well, I guess they get in the way, which they kind of do. They are ridiculously tall. But yeah, FX chips, just huge clocks, not really the performance to justify it. Like, if we look at comparison scores, they're going to have to... Okay, I have no idea how to get to, like... This is going to take a while. So anyway, basically any modern CPU is below like is in like this 5-second range, you know. And then there's the FX chips, which even if, with good memory settings and pushing insane clocks, you're barely getting under the 10-second mark. Yeah, like I don't even know where that's going to be. It's probably going to be somewhere in the multiple thousands. Let's see. Did I nail it? Nope. Yeah, even a 5 well, no, a 5.4 gigahertz 2500K will run SuperPi 1M in 6 seconds, 949 seconds. Meanwhile, the FX8320 at almost 8 gigahertz is struggling to get below 10 seconds. So, yeah, it gives you some idea of the disparity in the single-threaded performance of FX chips and Intel chips. And 1M is it is just basically just a CPU benchmark. It does care a little bit about the memory, but not that much. Yeah, so this is just kind of a cool score because you don't get to see CPUs doing almost 8 gigahertz for really anything, like much less benchmarks. Like, for a lot of CPUs, it's a struggle to do an 8 gigahertz validation, and then like a 7.9. Well, SuperPi 1M is basically a validation, but still, just an insane frequency, and Unity of Saints managed to get second place in the FX8320 rankings. The first place is actually held by Bones, who ran 8.3 gigahertz for 1M, which is absolutely insane. Like, his chip is ludicrous. So, yeah. Anyway, we also have some binning information from Unity. Apparently, this is the fourth chip he tried, and it's 1532 from the PGS batch. 1532, I think that's a bit late production to be a good CPU. Or maybe... Yeah, I'm not sure. Apparently, there's like a date past which actually with FX chips, it's super weird because you can get a lot of FX chips that are actually really good on like ambient cooling, like water cooling, air cooling, that kind of thing, and they'll do really high frequencies, and then you take them on liquid nitrogen and they just brick wall at some really low voltage. But we don't have an accurate voltage readout, so we won't know if that's what's going on with this chip. And when I say really low voltage, I mean like 1.9 volts. Because FX on some chips they scale to like 2.05 or more. Like absolutely, like these chips are just like, they aren't good, but you know, they aren't really good in terms of performance, but in terms of overclocking, they're just really fun to run, except for the part where you need to find a motherboard that doesn't like shut down for multi-core workloads, which admittedly, you know, yeah, you can get the crosshairs. But I thought the crosshair didn't have 1 core per module mode, so that's really interesting that he's running it with 4 cores. I mean, you know, disabling the unnecessary cores still helps you with thermals, but like if I saw this on a Gigabyte motherboard or an ASRock motherboard or the original crosshair, I would assume it's in 1 core per module mode, because that is actually super helpful. It even helps for validations because it just spreads the heat across more of the die more evenly. Because if you have 2 cores in one module, then the heat produced by the cores is right next to each other instead of, you know, every other module, like all the way in the next module. But yeah. So AM3 Plus, just an awesome platform, and Unity of Saints here just sort of showing why with the 7.9 gigahertz FX8320 SuperPi 1M run. So yeah, that is it for this week's HWbot score roundup. Again, I do apologize that it is so late, but at least it's here, because we do have like epic scores that like really some really epic scores came along in the last week. And so that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check out the links to them. And yeah, that is it for the video. So thank you for watching, and goodbye.